I am a big NASA fan. I'm a big tree fan. So I'm here to talk about using lasers from space to measure trees in 3 dimensions and essentially map their forest carbon and biomass. Talking on behalf of a long list of co-authors, and many of them are not listed on this slide, but we're focusing on 2 NASA missions, NASA's JEDI and ISAT-2. Why do we care about mapping forests in 3D and forest carbon? Forests are a huge part of the climate issue, right? Forests are naturally sponging a whopping 31% of the carbon that we're pushing up into the atmosphere. But as we deforest areas, we're losing a lot of carbon to the atmosphere. We don't know how much, we don't know where, because we've never had the right technology in space to map it in 3 dimensions before until now. How much is there? We don't know. We're going to know really soon, but we can't measure biomass directly. The best we can really do is to shoot lasers from space at trees and measure the volume. The traditional way is to tree hug, but we obviously cannot hug every tree on Earth. Hence, JEDI. Okay, so there is a Star Wars theme. May the Force be with you is kind of our mission slogan. And this was the promotional video that was put out before JEDI was launched back in December 2018 in the before times. So JEDI has been up on the International Space Station collecting LiDAR waveforms for a few years now, and we finally are turning those waveforms into estimates of carbon, and that product was just released. So here's a picture of us at the JEDI launch. Once the instrument was installed on the ISS, JEDI has 3 lasers in it. One of them split into 2 beams, and then those 4 beams are dithered back and forth to make these 8 ground tracks. So if you look at JEDI data, you'll see these 8 lines under the ISS. Each laser pulse illuminates about a 25-meter diameter circle, and then the photons in that LiDAR pulse bounce back to the ISS, giving us this orange squiggle, which is a waveform. So for those of you who are familiar with airborne LiDAR, it looks like what's in the bottom left. That's not what JEDI looks like at all, so try not to be disappointed. A waveform LiDAR, it's essentially these squiggles that give you height and canopy cover and biomass for a series of billions of samples, waveform samples. So a big part of what I've been doing is trying to translate these waveforms into estimates of carbon and biomass for all of our carbon science needs. So to do that, we take places where people have gone out and done the tree hugging, done the field estimation of biomass, and also have airborne LiDAR. And we turn the airborne LiDAR into simulated JEDI waveforms, and we build up empirical models. So this is the training database that went into our version 1 model, and that's the product that just got released last week. There's a little bit in Australia. There's more coming, so we'll improve the models in Australia soon. But this is where we're training our data with, our models with. So our products are really only going to be as good as the training data that went into them. We build super simple models, so try not to let your eyes glaze over here, but essentially we take these waveforms. Here's an example from the Brazilian Amazon. We plug them through empirical models, and per waveform, we get an estimate of biomass. For this waveform, we have an estimate of 149 tons per hectare of carbon. And then we apply those models to the billions of all on-orbit waveforms, and then we grid them up to 1 kilometer products. So we have products coming out. The L4A, JEDI's L4A product was released just last week, just on Thursday, so brand new. But we have products for elevation, height, canopy cover as well. So both the sample products at the 25-meter resolution and then gridded 1 kilometer versions. So for those of you who might have noticed on the last slide that we're kind of capping the world around 50 degrees north, that's because the ISS doesn't go over the poles. I'm Canadian, so this was a problem for Canada, but we have a second NASA laser that we've essentially used to fill in that northern gap. It's called ISAT-2, and so with ISAT-2 and JEDI, we have these global biomass products. Cool, so first cut of the products probably can be improved. How are we going to make them better? Many ways, but one of the best ways is to improve our training data. So more training plots, better training data. Terrestrial laser scanning, we think, is one of the best new technologies, which I'm sure many of you are familiar with, that will really help us train these models better. So here you see an animation of some terrestrial laser scanning data. Instead of the traditional way of measuring or estimating biomass, when you go out and you literally hug a tree, you measure its diameter, TLS gives us the entire woody volume of these trees. And so we are hoping that as a global community, we can get together and we can put in new field plots with terrestrial laser scanning and airborne LiDAR. And we're trying to coordinate under GEO as a new GEO activity called GeoTrees, essentially trying to get like big international collaboration going here. So love to engage with some folks from Australia. We also want this to be more open. So we're moving beyond open data at NASA to open science. So when you see a biomass product go online, you should be able to look at the code that was used to make that product. So we have a new platform called the MAP platform between NASA and ESA that is really enabling this open science, linking cloud computing to the data to the products. Okay, so then I will finalize with some of my favorite things we're doing right now, two science applications. One is on the forest conservation side, which is essentially asking the question, with JEDI data, can we quantify how effective global forest protected areas are at protecting carbon? And so spoiler alert, it's very important and there's a lot of carbon that's being protected. A new question that we're also asking is, are the most carbon rich, the most carbon dense forests, are those being protected? Are there areas in the world that are incredibly important for conservation that are not currently protected? I don't have a spoiler on this yet because this is an active research question we're working on. So this was just like a tiny little sample of the stuff that we're doing at NASA with LiDAR, but there's a lot of data coming online in the future, not just LiDAR missions, but a lot of radar missions. And so we think this is a really exciting time for remote sensing of forest structure and biomass. There's some cool stuff, especially in 2023, that will start coming online. So please access the JEDI data products, tell us if they're good or they're bad, and thank you to everybody who has provided CalVal data for our mission. You can follow us following the Star Wars theme for JEDI at JEDI Knights on Twitter, and thank you so much for the opportunity to do this extremely quick talk.